Good afternoon, Doctor. My name is Daniel Trihendato Tandra. In here, I will explain to you some aspect of the project in the presentation. First of all, we found a real stakeholder with a real issue in Angola, which is a bank, Banco de Punca e Credito (BPC) in Africa. So it is a very traditional bank where you have to go to the ATM machines and the central banks to do transfer, saving, and etc. Here we're trying to modernize it in its system to embrace the banking and expand access to digital service, especially in those areas because BPC is a big thing in Angola. Here we have our logical ERD on the right side and our conceptual ERD on the left side. So here we have many entities such as customer, account, staff, bill payment, transaction, audit trail, and also subscription. And on the right side, it is expanded to what each of those entities have aligns with. This is the normal entities and the normal ERD for a bank in a low system. So let us continue. So these are the descriptions of the relationships and the entity. For example, we have customer have a relationships of owns to account and has a multiplicity of 1 to many and then 0 to many for it. And also for the descriptions of the entity, we can see on the right side for what are those means and the occurrence of it. And then on the below left side and the right side, here are the examples of each of the entities, and inside of those are the attributes, and then whether they are foreign keys or for outside the descriptions, and we also the data type and null or multi-valued. So let us continue. And here, Doctor, we have our mobile visualization of what we're going to make. So on the left side, it's a subscription package. We can pay monthly, annual, or one time. And down below, we have our agreed to terms and conditions, and then the explanation of the subscription. Also, you have the home button, transaction history, bill payment, and fund transfer. On the middle side and the right side are the admin account page for looking at each of the customers they have and what are their names, address, and emails. On the right side, each of the customers transactions. So we can see there's a unique invoice with a unique amount.
Normalization is the process of organizing a database to reduce redundancy and ensure data integrity. This involves applying normal forms such as first normal form, second normal form, third normal form. The result is a database free of unnecessary duplicates, reducing storage costs and improving efficiency when handling banking operation like transactions and subscription, for example. So we have the customer table, account table, transaction table, bill payment table, subscription, staff table, audit trail table. So actually, these schemas ensure the database structure supports seamless banking operation while maintaining data accuracy and consistent the admin dashboard and the audit trail page. So starting with the admin page. So actually, as we see in the top, we can see greeting and admin ID providing a personalized experience while ensuring this user-friendly layout ensures admin can navigate quickly and address system needs efficiently. This page is crucial for maintaining transparency and accountability in the system. So it displays detailed log of all admin actions with key attributes, date and time, performed by who, and the details. So let's take an example. So log ID L001, for example, records that an admin added a customer at 9 a.m. on January 1st, 2024. So this comprehensive logging system not only helps track activities, but also refers system security. In conclusion, these two screens, admin dashboard and audit trail page, serve the backbone of the e-banking platform's administrative functionality. Together, they empower admin to manage system effectively while ensuring transparency and security. We use the left join to match performed by in audit trail with the user ID. In users, if there is no match, the username and email. This filters the actions to only show the performed by a specific admin. After joining the table, it applies a where clause to only show actions The third query is we use group by to group by the data part of audit data of audit date and counts the total. So we use the group by to see the total action in every date.
See this is the aspect is HTML for the DDL. First we have stable customer, second we have table income, transaction, then table subscription, table staff, table audit trail, second account, regular customer, current account, this is subscription, premium subscription, table manager, table transaction, transaction, login audit, transaction. So first, when customer log into their account, select customer ID, password ID, customer, so it's here. So then this is for the this is for the account, so it's the dashboard page. No, no. Just consider. So this is for the dashboard page. So you can see the balance is reduced. So now balance is this name. So this.
So the next one is for TML. So for customer, account, transaction, bill payment, subscription, staff, audit trail, until audit trail, I'm gonna use separate lines, so there will be a lot of lines. So insert into account, and then the relation name, and then relation attributes, and then we input the values for the relation attributes. So A1, A001 is account ID, account type is savings, and so on. And then it's the same as transaction, insert into transaction ID and time, so that's transaction attribute, so that's all the same for subscription until audit trail. But for regular customer until so on, I'm gonna combine them into one line instead of multiple lines like this. So insert into regular customer, and then regular customer attributes like this, and then the values, so there will be 3 values. So regular customer 1, 2, and 3, and then same as saving account, current account, premium subscription, basic subscription, manager, clerk, bill payment, transaction, transfer transaction, login audit, and transaction audit. All of them will be the same. Okay, so my name is Dan Reflected, and I'm gonna demo for 3 queries for the database. So the first one, I'm gonna use natural join. So maybe the scenario is to fetch customer details along with their accounts. So the query will be so this will be the natural join. So it combines customer and account. Natural join automatically matches columns with the same name and compatible data types. In this case, it joins customer and account on customer ID column. Okay, so the next query will be equijoin. So maybe the scenario is fetch transaction along with corresponding account details. So this will be the query. So an equijoin explicitly specifies the condition for joining tables using the on class. Here, the transaction and account are joined using the account ID. So as you can see here, on transaction, account ID equals to account ID. So this is the second query, and now for the third query, I'm gonna use the left outer join. So this is the example for left outer join query. So a left outer join retrieves all records from the left table, so that's the customer, and the matching rows from the right table, so that's subscription. If there's no match, null is returned for the right tables column. So yeah, this is the output for the left outer join. This is the output for equijoin query, and then this is the output for natural join query. So that's all.